Hi, my name is Jachim Coudenys. I work for a hosting company in Belgium, and today I will be talking about how to use Git to write history by keeping a diary. Who here keeps a real diary, except from Git? Nobody? So, because nobody is using a diary, a quick definition. A diary is a record with discrete entries arranged by date, reporting on what has happened over the course of the day or another period. Wikipedia goes further and says that diaries are undertaken for institutional purposes, play a role in many aspects of human civilization, including government records, business ledgers, and military records. So keeping track of things is something that is done a long time and has proved to be useful. And we also do that, but for our case, it's about code. We all write code, and we have to communicate to other people what our code is doing. So the primary goal of a software developer should be to communicate their intent to future developers. When we say future developers, 9 out of 10, that's you within 3 months. So if you're writing code, you have to establish some kind of context that you had in your head, so it can be reconstructed in the head of the future developer. Everybody knows this scenario. You look at 2 lines of code, and those were written a few months ago. As developers, we read more code than we write, so we have to start to compile that code and construct what that code is doing in our head. So you start to think about what's happening. You start to make a lot of things in your head. If this would come, so we end up with a lot of information in our head, the context of those 2 lines, and then somebody comes along and asks, "Hey, did you get that email?" And then the whole context you had in your head is gone, and you have to start over again. So what we want to do is write a lot of documentation, and not only code documentation or just API documentation. We can write a lot of documentation using a version control system. I say version control system in general because that's just keeping track of versions, but this talk will focus on Git because everybody uses Git. Who doesn't use Git? Excellent. So, in some kind of way, you all keep diaries, and we want to, or I want to help you write your diary a bit better. So re-establishing the context of a piece of code is wasteful. We can't avoid it completely, so our efforts should go to reducing it as much as possible. Commit messages can do exactly that, and as a result, a commit message shows whether a developer is a good collaborator. So you're not writing commit messages for yourself, you're mostly writing for other users that are using your code or want to look why a change has happened. So, who's familiar with the Richardson maturity model? I have one. You all be familiar with it because it's just the different levels of REST. So we have the level 1, which is just plain old XML. Then we can apply some more principles to it. So then you're on level 1, and you go even further until you reached the holy grail of REST. This has nothing to do with this talk, but this is the model I will use to lay out this talk. So I have my own commit maturity model. It starts with the basics, and then we go a level up every time. Every level we talk about how you commit, how you construct commits, how messages should be constructed, and then some CLI tools and some visualizations for that level. So, everybody ready? A quick recap of Git basics, because a lot of the advanced stuff in the end of the presentation will refer back to a lot of these principles. So this is not Git. This is just your local version control system. That could be local history in your IDE, or that could be file1.php, file2.php, file final.php, file final.1.php. So that's the version database that you use on your local computer. It's not useful, so we went to a central version control system. You had CVS and Subversion. These are keeping track of the complete history on the server, and on your local computer, just checking out a specific version of that file or that tree. Next up is a distributed version control system, like Git. And in Git, every user has his own version database on its local computer. This means that you can do a lot of local things, writing history, before pushing it to a server or another user. So we will use this magic or functionality to write better commits and commit messages. So a centralized version control system uses deltas of a file. So if you want version 3 of a project, it will just take the first file and apply all the deltas to it and send you that file to your local computer. In Git, it always has a snapshot of the current, so that's your working copy. And it refers back to previous versions. So everything in Git is a reference to a previous version or a parent version or stuff like that. And the most important thing is the different stages. So you have your .git directory. That's the complete version the complete version database that you downloaded from the server or got from another user. And when you check out the project, it will just create some kind of snapshot of the state of the files and put it in the working copy, the working directory. And then you can modify some files, add it to the staging area, and from there on you can commit it back to the repository. Most of the times, a lot of users use git commit -a-m, so you kind of skip the whole staging area and just push it right into the repository, which is fine in most of the cases, but you want to be able to add different files to the staging area before you continue. More on that later. So here you have the logic that Git is using by referencing back to the previous version. So the red boxes are branches, and they are just a file in the .git directory which contains a pointer to a specific version. And then the yellow one is the head, and this is where the current checked out directory is at. So if you start to change, you will see that you just move ahead, move forward with versions. If you start adding to master, then you start to create branches. So basic stuff in a version control. So we're at level 0, and this is the plain old XML. Here we have the plain old random commit messages, where people just push stuff into Git, which is not good. So we're ready for level 1, now that we have the basics straight out. So if we want to create commit messages, if we want to create commits, we have to create atomic commits. Atomic commits are preferably small, and they solve one problem or one case at a time. So the idea here of an atomic commit is if you check out that version, the project still works. So if you split up like the login form and the backend of it in a different commit that's not atomic, because you can't use the form without the backend logic. The other way around counts too. If you create a commit message and say adding a form and tweaking the UI, the moment you use and in your commit message, you have the flag that you should break it up and just create more commits. So this is level 0 for a commit. Commit messages should tell you what and why you did something instead of how you did it. Because people can just open the diff and see how you did it, but you have to write why you did a change, because it's not always clear from the changes you made. The reason I use Git the most is because you can have a subject and a body, and not a lot of people know that, because most of the people just use the subject. But you can dump a lot of information, extra paragraphs in the body of a commit message. Only do that if it's needed. If it's a small change, like change the typo of that word, you don't have to include a link to the dictionary somewhere. Only use it if it's necessary. But please use decent commit messages. This is a graph of 150 million commits, and all the merge commits messages were ignored. And this is the top 30. So at the top you have initial commit, which is not really something people use or type in, but it's just if you follow the GitHub README, that's your first commit message. The update README file is if you hit the edit button on GitHub and you just want to save it. Nobody takes the effort to say why they changed it. They just hit the submit button. So those two you can ignore, but the rest is not so good. Dummy, fix, cleanup, empty, stuff like that. Git is not a backup system. Git is a diary system. So if you start writing decent commit messages, you can start using git log and all the variations of it, because that's what we want to accomplish. So you have git log. You can see who committed it, when, and here you see the subject, and this has one line. This has a body. You can do more stuff with git log. You can grep things. So here we grep for Q, and it's finding the keyword Q in the subject. So it will return everything that has a Q in it. But the one that's very useful is the uppercase S, which searches for changes in the code with that string in it. So here I search for a bcrypt, and it's showing that it's not showing bcrypt in the commit message, but it's showing that it was added in a changed line. So if you pull down some code from a project and you get an undefined method exception, you can just copy that method, put it in the git log search, and you know exactly who removed it or added it, why, stuff like that. So this is a very useful command. All right, that was level 1. We go to level 2, again with how to create atomic commits. Now we are going to create a bit more pure atomic commits. So the big one here is always commit code formatting in a different commit. Because if you had your IDE remove all the trailing spaces, and it's the first time you open that file, and you do one change, and you save the file, and you end up with like 4,000 changed files, nobody will see the commit you wanted to do, because it was just get lost in the formatting. And if you have that, you can you can create different commits from a workspace that's dirty. So if you were hacking like 2 hours on something and you needed to do all the changes because otherwise it wouldn't work, you still want to change. You still want to only add chunks of the changed code to the repository. And therefore, you can use git add patch or git add interactive. And those allow you to add only chunks of changed files. So I have a little video of the Laravel repository. And I'm going to make some useless changes just to show, just to have a diff so that I can show you. So I'm going to add my name to the sponsors. It will not be accepted if I create a pull request, I think. And to emulate an IDE, I add a new line at the end of the file. So now I have one changed file. I will change another file, add an useless comments on it. So I have different files. So now I have 2 files that are changed, but they contain different changes. So here you can see I have 2 legit changes, and the red dot, the red plus sign, is just the white space of the new line at the end of the file. So I can do git add -p. And I get the first chunk that I changed, and then I get this excellent explainable set of options. So I have a lot of options here. I can change it, I can add it to the staging area. I can skip it. And for now, I will skip this one because I want to add the formatting first. So this means I have to use Y. So now I have part of a file in the staging area. And the last change here we will ignore, and instead of using the no, we do the D, which means just ignore the rest of the file if we change. So now you can see that we have one line in the staging area. This is the staging area, and we will commit the new line. So now I still have 2 edited files, but they are only the lines I want to add. So with git add -p, it's very easy to split up files. Instead of only selecting the different files, you can also add chunks of a file to it. So here we just, with the previous git add, we are just making sure we split up the commits. But sometimes we have just done a commit that should be fixed, and we should rewrite history if it's necessary. I talked about that Git is distributed. It's private, so as long as you don't push to the server, nobody will see what you're doing, and it's very flexible. And because it's flexible, it allows us to rewrite the history we have locally before pushing it to a server. The easiest way is git commit --amend, which just allows you to amend the previous commit, which is nice if you do git commit and the moment you hit save, you see that there was a typo in the commit message. Then you can do git commit --amend and you can change it. But for the real work, you have git rebase interactive. So I have a small demo here. I will create a new repository, and I will add some files to it, and deliberately add some typos to it. So let's create a README file. And I will just add it with the GitHub conventions, initial commit, don't do it. This is just for the demo. So now I have added an empty file. I have my first commit, and here we have the A92. This is the Git commit ID. So let's add some changes to it. The second commit I make will contain a typo in the file. And I will commit it. I will commit the typo with a commit message containing a typo. So we created an error in the file, and we created a typo in the commit message. So I just noticed that there was a typo in the commit message, so I can do git commit -- amend, fix the typo, and I will create a new commit. So the previous commit will be discarded, and we have a new commit ID. So now we have 2 commits ready to be edited. So let's add another line. So this is just a correct commit that we will construct. So now we commit it to our repository. This is even worse than a live demo. So this is the correct commit. So this commit is one we want to keep. But now we see that we have the typo in the file itself. So if we want to change that, we can't. What most people do are just creating an extra commit and saying this fixes a typo from this commit. But that leaves us with too many. Commits that are just not needed. But we can't use git commit -- amend because that only applies to the previous commit. So what we can do is use git rebase, and what rebase will do. So notice here that the commit IDs will change if we do a rebase because we are effectively rewriting history. This is why if you do a rebase for a branch that's already on a server, you will have to use --force because you're rewriting the history for the other people too. So now I do a git rebase, and I say from head go 3 commits back, and then I have a little playbook I can create to say what we want to do with the different commits. So with the first commit, we just want to edit that because we want to change the typo there. The second commit, it will just apply, it will just use, and the third commit, it will drop because we will apply the fix manually and rewrite the first one. So now it has stacked all the patch files, and we can create a new commit ID or a new commit by fixing this error. The problem here is that normally, so here we will have the famous rebase nightmare because the diff is not large enough for Git to know how to apply the previous line. So if we continue now, so notice that the commit ID has changed. And if we continue now, the second commit will be applied to it, but we'll have we have a merge conflict because there's not enough data in the file. So the first line has changed, so Git doesn't know where to append the next patch. So we fix this real quick. We will add that to the repository. And the last stage will just drop the commit, the typo fix commit that we don't need anymore. And then we will have rewritten history and can push it to a server, and everything is just fine. So this is a trivial example, but rewriting history helps you to tidy things up and have a clean history. Okay, now time for some good commit messages. If you write a commit message, think about the length of it, because it's pretty annoying if you on a small, not a small computer, but if you're in a terminal and you just can't read the rest of the commit ID. So the good baseline is use 50 characters for the subject, and then use the 72 character wrap for the body. Little piece of advice: stop using git commit -m, because you will only be able to supply the subject. If you use git commit, it will open the Vim, and then you can, or another editor, and then you can add all the content you want. Now that you have the whole body, that you can include things in it, reference a lot. It's just you have a whole lot of space to add references to tickets. If you used some pattern link to the pattern page, the manual page, just put as much information as possible in it, because you will like to see how to create the context of that commit you made in a few months, years, and use URLs so you can click them. So the reason why you want to keep the length in mind is if you do a one-line, git log one-line, you can read what's changing. As you saw before, if you do git rebase interactive, you only see the subject, so you want to quickly see what the change was about. If you do the git merge and you ask for a summary, it will use the subject in there. Short log uses it, etc. So it's just make sure it fits on 50 characters, and it explains what you were doing. GitHub is, if you're typing your subject and you're going over 50 characters, it will kindly show you to stop doing that and just start writing in the body. It will even truncate your Git subject in the interface and just add a ... and put the rest in the body. So it's clear for everyone what's going on. Another useful tool is the graph. Not this graph, but the git log graph. So this is the ASCII art git log graph that Git shows you. What you want to do here is check this out every once in a while to see if your branching strategy is actually good. So this is GitLab, and it uses its own representation of the graph. And here you can see the red line is master, where all the feature branches are merged in. So this is nice. A feature branch going out, going back in. This is some other project that's just merging stuff from the remote server into its feature branch. It's merging master into the branch. So you have all these lines that are crossing, and if you have this on your project, you have to rethink on how you want to do your branching, because a pretty annoying thing are merge bubbles. Merge bubbles are if you use git pull and you don't use rebase to pull your changes in, it will create a commit. It will create a merge commit from the remote server, and it will just create little bubbles in your graph. So if you search for merge branch master from GitHub, on GitHub you get like 5 million commits that are just useless. This is a merge bubble. So you have your own code, and then you create a merge commit which includes the code of the remote party. And it's just, if you use rebase, it's just nicer that you have a straight line. So the difference between a merge commit and rebase. So here we have master, which is 2 commits ahead of where we started our feature branch. And if you want to include the changes of master in your feature branch, you can do git merge master, but that will create a new commit in your feature branch, and it's not nice. So if you use git rebase, it will. So here we can see that we have a new commit, which is the last one with the asterisk. And if you use git rebase, it will just create totally new commits. So it will keep the patches of the diffs of the 3 commits in memory. It will create a new branch, and it will just apply the 3 commits on that branch. So in that way, you have a smooth line in your Git graph. There's another thing called squashing. I want to say the Git merge commits are good in the other way. So if you if you enter the feature branch and you want to put it in master, then a merge commit is excellent, but not in all the cases. There's something different, what's called squashing. So you have 2 commits D and E on your feature branch, and if you want to put it on master, you can just squash them together and put them as 1 commit in master. I'm not a big fan of that because you lose the nicely constructed Git commits that I just taught you how to create, and you just remove all the information and squash them together in 1 commit. It has some advantages for like rewriting history and tidying up your history, but it's not. I don't like it for merging Git branches into master. Okay, which brings us to level 3. Here we will write suburb commit messages, and if you start to write a commit message, you just have to answer some basic questions like, why was this change necessary? How does it address the issue? What side effects it may have? So if people see strange things, they can read about it in the Git subject. And here's an example of Torvalds, who created Git, and he is making a commit, explaining how to write a good commit with a good commit message. So here you can see that it has a header line, it has a body, it can have some bullet points, so you can include a lot of information, and in the end, you can add some meta descriptions or meta information to it. So there's a lot of things you can do with that. You can include a ticket ID there. So there's a lot of things you can include. This is a commit of the Bitcoin repository. The subject is change default confirm target from 2 to 6. With that subject alone, it's not useful because if you open the diff, you will just see the number 2 changing to 6. But then he includes a lot of information about, they discussed it on IRC, then there's ticket references in it. So if people do want to check out why that value changed, they know exactly where to look and why the change was there. So this is a very good commit message. The commit message, you want to have it in the imperative language, and that's this fix bug instead of fix this bug or this fixed bug. It follows the structure that Git is using when it is creating commit messages for you on your behalf. So if you do a git merge, it will just say merge this branch. So it's a nice way of always using the same way of describing your commit. And the easiest way to remember how to do it is just if applied this commit well, and if the subject reads like a normal sentence, this is a very nice commit message. And the commit message, it's very useful to include commit IDs of previous commits. Git revert does this. If you say git revert and a commit ID, it will create a reverse diff, and it will include this will of this reverted of reverses the other commit. And if you're using GUI or GitHub, you can just click on that. If you're using GitLab, for instance, it will even include a reference from your new commit and the comment box from the old commit. So if you're rewriting a typo or if you're fixing a commit that does some strange behavior, just include that commit ID in your new commit, so it's easy to traverse where some code came from. Since you have the whole body to include information, I often just put in whole stack traces of what happened. So I fix some kind of error, and I just put in the whole stack trace and the body. I include links to all the relevant tickets, stuff like that. So you can put a lot of information in it, so please use it. So you can, by using hooks, you can do even more with the commits you're making. By using hooks, you can automate stuff. You can like close issues by referencing a ticket in it and having the name fix bug from that ticket. And then you can, then the receiving system can close tickets for you. You could even, if you have the strategy that you have to include an issue number in every commit, and you use like bugfix/issue_x as a branching strategy, you can use a hook. If you do git commit, and it opens the editor, you can write a hook in between, which parses the ticket ID from the branch, and already include that in the editor. So it's already there. You just have to add some more information. So you can do a lot of things. You can even validate the message format. Does it include a ticket number? Is it in the imperative language? So hooks are helpful for doing even more with your commits. Small note on issue numbers in commits. I kind of always use them in private projects or projects at my company, because if you're not using, unless you're in development, but if you're not using a ticket ID in your commit, that means you're just changing stuff because you want to change it. A change has to be triggered from some kind of ticket, and that may be refactoring stuff or fixing bugs or tidying things up. But you should always include an issue number. I'm kind of on the fence for projects on GitHub because GitHub, like always, adds references in a ticket if you to the commit. So if you append or preprint your commits with a ticket number, your ticket list comments will just get out of hand. So now that we use Git in a proper way by always splitting up commits and writing good commit messages, we know every line of code is always documented. If you use git blame on a file, you can see for every line when it was changed and by who it was changed. If you then click on or open the commit ID, and you can have more information about why a change was made, and you can click even further and see what happened or why they did something. So you can always look for people who broke something in your code. If you do that, also add an alias to git blame, do git praise if you see some good code. So then you see You can do a thumbs up for the developer who put that line of code. So, in summary, there are a lot of ways of doing these kind of things, like how you format commits and what should go into the repository. But always make sure in a project-wide or company-wide that everybody's doing the same thing. So it's always predictable how a commit message or how a commit is constructed. Agree on a format and document how to do the style of the commits, what should be included in the commits. Do you always want the body? Do you always want some metadata at the bottom? Ditch GUIs and start using the command line. I personally use both, but yeah, sometimes the GUI is just it's a bit overwhelming, but it stays true to how Git does things, because some GUIs just skip a lot of things, name things differently. So if you want to create some better commits, start using the command line. Before you commit, read your code. So you can use git diff on your working copy and see exactly what changed. By reading your code, always you go over every chunk, and if you see that you are mixing code that should be separately, just split it up and create atomic commits. So don't do code backups or end of day code drops, or you're hacking the whole day and then I'm going home, git push. You put all the code on the server, so it's backupped, but it's not working. Just Git doesn't care if it has a lot of commits. Just put as many in as you want. So don't use it as a backup system. Look at the commit graph on how your commits are affecting that. If you're doing a lot of crossing branches, just stop for a minute, look how you can change your branching technique. So you can see that on how you commit things, how merges go. You can use the graph for all those things. And if it's necessary, rewrite history. You saw the very basics of how to do it. And it's not that bad. Git rebase has a bad name because you always have millions of merge conflicts. But if you use it in a proper way, it's very powerful. And that concludes my talk. Again, you can find me on Twitter. I work at a company called Combel, and I run a local user group in Belgium.
You talk about don't use it as a backup system, don't do the end of day thing. I find myself doing that as well. Have you got any suggestions to wean oneself off that?
I said don't use it as a backup system. You have to use it as a backup system, but it should be a side effect of all the things that you do. I think it's just like a habit that every once in a while you just look how much code you changed, and if it's still a single responsibility. A nice hint was if you go out for lunch or you go to the bathroom and you have something ready to commit, commit that. So if you come back, you can just read the previous commit and know where you left off and go a bit further. But the problem is with end of day code uploads, that is just you do a git blame of some code that has changed, and you have the diff of a complete day. So you have to. It's difficult to see it from the committing side, but you have to use git log a lot, and then you see how you. So you just have to check out do a git log and look for a month range of previous of last year, and just see if you can understand or how you would do things differently. So maybe that could help splitting up your commits. If that answers your question. No.
Yeah, no, my other thing was about if I'm halfway through a feature, but it's the end of the day, and I feel bad about not committing or not pushing just in case my computer explodes or something like that.
Well, you're on a different branch.
Yeah.
Most of the time, so you can. If you're on a separate branch that you pushed to the server and nobody else has checked it out, you can still rewrite the history of that, because if you do the minus force, people will getting errors if they pull. But if nobody else checked it out, you could just rewrite the history of that. So if you're concerned about backups like that, you can just put a work in progress branch, push it over there, and then rewrite the history the next day. Maybe that.
Thank you.
I really like good commit messages, and I was wondering, what would you say to someone who is not so interested in doing it, or if you had any experience in a company where you wanted to introduce better commit messages, and how did you do this in the team? If you introduced some kind of talk to kind of talk about the things that you want to consistently introduce into your commit and your branching system?
Yeah, well, you have to educate some people. It's just, like I said, you don't see the advantages if only by committing things. You have to use the history. You have to be able to see the advantages from the other side. So it's a bit, chicken and egg. You have to do it for a while to see the advantages, but. Look at open source projects, point them to there. So they have code bases that go years back, and they have to fix stuff. So they have to look why they did a change last year. So maybe try it like that. But yeah, you have to educate people. Say maybe like show them the graph. If the graph is jumping too much, just say this is not good. Just hold their hands and make sure they're walking the straight path.
Yeah, just try to dynamize it a little bit.
Sorry?
Dynamize it. Try to engage them into do it as well.
All right.
Thank you very much.
Thank you.
Thank you very much for the talk. Do you think every commit should be runnable so the system don't crash, or because if you check in very small commits, sometimes it doesn't work together and the system breaks?
Yeah, there will be commits that are not purely atomic, but you should really aim for that. I don't know an example off the top of my head, but try to do it as much as possible. Or break them up afterwards by rewriting history. It's a process you have to go through, I think.
Okay, thanks.
All right, I think the time's up. Thank you very much, and enjoy the rest of the conference.